Ohm's law. Voltage equals current times resistance. This equation is the foundation of every electrical system. Whether you're designing a phone charger or a power grid, you start here. Understanding how voltage, current, and resistance relate lets you calculate what happens in any circuit. This is day one stuff.
Microcontrollers. This is where hardware meets software. You program an Arduino or ESP32 to control pins, blink LEDs, and read sensors. You learn about GPIO, digital and analog signals. This is your first real project, making something actually work in the physical world.
Robot. Now you're reading temperature, distance, light. You're controlling motors with PWM to adjust speed. This is where you build that classic four-wheel robot. It can sense obstacles and move around them. You're combining input and output. Practical engineering.
Wi-Fi and MQTT. Your devices need to talk. I2C, SPI, and UART let sensors and chips communicate locally. MQTT and HTTP connect them to the internet. Now you're building IoT systems. Your temperature sensor sends data to your phone. Your robot gets controlled remotely. Smart devices.
RTOS, real-time operating systems. You're not running one program anymore. You're managing multiple tasks simultaneously. Read sensors, control motors, handle communication, all at once with precise timing. Critical for drones, medical devices, automotive systems, anything where timing matters.
System on chip. This is how your smartphone fits a powerful computer in your pocket. CPU, GPU, memory, sensors, all integrated on one chip. You learn ARM processors, memory management, power efficiency. Understanding SoC design shows you how modern devices achieve incredible performance in tiny packages.
AI brain, edge AI, and TinyML. You're running neural networks on microcontrollers. Image recognition, voice detection, gesture control, all happening locally on a device smaller than a coin. No cloud, no internet. This is how smart doorbells detect people, how earbuds recognize commands. Machine learning meets embedded systems.
Humanoid robot. Advanced robotics. With RTOS, the Robot Operating System framework lets you build autonomous systems. Multiple sensors working together, path planning, simultaneous localization and mapping. This is how humanoid robots walk, how self-driving cars navigate. From blinking an LED to building intelligent machines.
8 levels, from Ohm's law to humanoid robots. Each level builds on the last. Master them in order. Which level are you at? Comment below. Subscribe for more.